Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you're new to this channel, or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to join the community debate, then go to nathanoakley.com and check out the Flat Earth Debate forum. And if you'd like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Zinda, Slick James Johnson, Paul, I can't quite see the screen, Nathan, Eben, Chocolate Saying, Brenda, Anon, and is it Johnny Globehead or John?
Quantum Eraser.
Quantum Eraser. Good to have you all.
Hello.
Hello, good to be here.
Hello. I just gave Brenda a phenomenon, by the way.
Good morning. Morning, Nathan.
All right, so a scientific law, right?
Hold on a second. Nathan, could you share my screen or no?
Yeah.
Hold on a second, because we're going to get back to the discussion. She said that Newton's law of gravity went through the scientific method, so we're going to go through the scientific method. She is going to support what she says. So, to get everybody up to speed, her natural phenomena observed so far was gravity, and I'm asking for the alternative hypothesis. That's where we're at. You're all up to date. What's Newton's hypothesis?
So it says Newton's laws are based on repeated experimental observation.
Now I'm going to ask you for the 10th time. You said your natural phenomena observed was gravity. The next step is alternative hypothesis. Give us Newton's hypothesis.
He wasn't formulating a theory of gravity. He was formulating the laws of gravity.
No, you're obfuscating. You said Newton's law went through the scientific method. I have the scientific method up here on screen. So you said the natural observed phenomena. Shut your pie hole. Natural phenomena observed was gravity. We're going through the scientific method as you claimed. You're going to support your claim right now. Is there anything that's particularly confusing about this?
This is the scientific method.
That's right. So, alternative hypothesis.
Laws are formulated
by
experimental observations.
Yeah, so experiments are hypothesis tests, and he's asking you for the hypothesis. So if they're done with experiments, it's established through experimentation, like you've just declared. Well, first we need the hypothesis, because we're going to perform, according to you, hypothesis tests. So just give me the hypothesis. What's Newton's hypothesis? Simple. Tell us.
Well, his hypothesis would be that if I drop this pin, it will fall at 8 meters per second. Right?
9.8.
9.8.
It's okay. We got it.
Hold on.
It's just right. It's okay. He's just writing it down.
If I drop an object, it will fall at 9.8 meters per second. That's the hypothesis. The alternative hypothesis. Well, actually, that's the null hypothesis. The null hypothesis.
The null hypothesis is the no difference hypothesis. So wait, before we get there, if I drop this pin, it will fall at 9.8 meters per second squared. Sorry about that.
That's the null hypothesis. The alternative
hypothesis. That's not the null.
Yes, it is. That's the null hypothesis.
This is not the null. I need a citation for that hypothesis, please.
So the alternative hypothesis.
I need a citation for the alternative hypothesis, please.
The alternative hypothesis is that if I drop this object, it will not fall at 9.8.
No, you got them backwards. You got them backwards.
Brenda,
null is
what does null mean?
Ask Quantum Eraser what the difference.
What does null mean, Brenda?
Ask him.
He knows. I'm asking you.
Okay, wait a second. We're going to solve this quick because it's a train wreck. First of all, you got the alternative hypothesis and null backwards. Second of all, this isn't a hypothesis, and this sure isn't Newton's hypothesis. You know why? Can you tell me why that's not Newton's hypothesis?
No, go ahead. Tell me.
We'll take it right from the Principia. 1 second. Give me a second, please.
Newton didn't have any math in his hypothesis.
From Newton, from the Principia, Isaac Newton, 1726. I have not, as yet, been able to discover the reason for these properties of gravity from phenomena. And I do not feign hypotheses. Or hypotheses non fingo equals I feign no hypothesis. I frame no hypothesis. I contrive no hypothesis. So you just made it up.
Yeah, that's
you
he's talking
just
about
made it up.
Talking about
Tell us
the
that
theory.
You just made it up.
He's talking about the theory.
No,
just admitted, Brenda, you sound like a jackass.
No, he's talking about the theory of gravity. He said, "I feign."
Newton never proposed this theory in his life.
Feign no reason. No reason, meaning I feign.
No, I do not feign hypotheses.
To explain the theory, I simply
there
describe
is no theory. Newton never proposed a single scientific theory in his life. We're talking about laws. Remember this? You said that Newton's law went through the scientific method. So we're back to this again.
Yes, it does.
Right.
That doesn't mean it.
So we're back here again, right? He had no hypothesis. This is not Newton's hypothesis because he didn't have one. We just read
he
that.
didn't explain. He did not explain the why. He explained the what.
He didn't have one. That's right. So it didn't go through the scientific method. My whole point.
That's not true.
So that's a great argument.
You don't have to have a theory.
You are a clown, period. We just demonstrated that. So thank you very much.
Linda, I think you're equating observation with experiment, and they're not the same thing.
Brenda thinks just doing observation is science. That's a problem. It is, right? Just like naming things. That's science, right? Naming things.
Yes,
you attach a name to something, that's science in it? Yeah, Brenda. Go ahead. Keep going.
Brenda, how is the mass of Earth calculated? Do you know what the mass of Earth is?
So Newton described gravity, right? He formulated his law.
Do you know what the mass of Earth is?
Oh, I'm not changing the subject.
I am changing the subject. Do you know what the mass of Earth is?
I'm not changing this. I'm not changing.
I am changing the subject. What is the mass of Earth?
I don't know.
You don't know? You don't know what the mass of Earth is? I thought you were a scientist. 5.96 trillion tons. How is the mass of Earth calculated?
You can weigh it.
It's weighed.
Yes.
That's how you know what it is.
Yes.
You don't know that it's calculated using Newton's gravitational constant?
Yeah, that's
weighed.
That's called weighing it.
Okay, so what's the calculation? How is it weighed?
You have two objects, right? In the formula, big G equals little g times mass 1 times mass 2 over the square root over r squared, right? So if you know one of the masses, you can calculate the other mass.
How do you calculate the difference between the radius of the sun and the earth?
If you we're not talking about the sun.
That's how Cavendish got the gravitational.
No, he didn't. No, he didn't.
You're saying he didn't?
No.
No.
So, how do you get the mass of the Earth then?
You get the mass of the Earth by weighing it.
Thank you. What scale did you use to weigh it? Was it something you can buy on Amazon?
No, you use a scale. Yes, you can weigh the Earth with a scale bought from
How
Amazon.
much is the scale worth? I mean, where do we place the scale on?
You'd have to get a rather expensive one that can.
I know it had to be big enough to fit Earth. I mean, where do you find? How do you build such a scale?
No, you don't have. It doesn't have to fit the Earth. It only has to fit the other mass.
What's the other mass?
Well, there's two masses, right? Mass 1 and mass 2.
Okay, so what's mass 1? What's mass 2?
Mass 1 would be the Earth. Mass 2 would be an object that you choose to weigh.
So what's the object that you choose to weigh?
Whatever you wish to choose.
The Earth,
so what
please.
do you choose?
Sorry, hold on a second. Hold on. We seem to have gone off on a slight tangent. We're talking about weighing. Brenda, you said any object. Okay, Earth.
No, mass 1 is Earth.
Yeah, and we're weighing that mass, right?
Right, and you weigh it by weighing another object, mass 2.
Okay, toothpick.
Sure, in principle, but not in practice. You could weigh the Earth using a toothpick.
Right, that's the stupidest thing I've ever heard.
No, it's not. In principle, you could do that. In practice, it would be incredibly difficult. We don't have scales sensitive enough to do
Maybe
that.
in the 1700s we had those
So you
scales.
say we do have a scale.
Yes, there are scales that are sensitive enough to make measurements that we can come to a approximation of the weight of the Earth.
So it's an approximation scale. I have those scales.
No, this is not.
I think it's like $1.99 at the general dollar store.
All scales have a degree of accuracy, right?
They're gravity meters, right? Scales are gravity meters?
Essentially, yes, they are.
Do you recommend one? I want to buy one.
Just use the one you use to weigh your weed with.
Weed? You mean after I mow the lawn?
I'd like to ask Brenda a question that might get us back on track a little bit, right? I know we're off in the weeds somewhere.
Go ahead.
Brenda, let's go back to the pen, okay? I observe a pen falling. So what I'm observing is something going from my hand to the floor. That is a what? Yes. What is the cause? What is the cause of the pen going from my hand to the floor? How would you determine? Okay, well then go through the process and walk us through that process of determining that that's gravity.
Well, we would just call that gravity because a force was applied to the pin. Right?
How would you prove it's a force? How would you prove it's a force?
So we just observe it, right? You let go and it moves.
No, we're still seeing a phenomenon, but you've got to prove it's a force.
Well, when you let go of it, did it hang in the air or did it fall?
Oh, sorry to interrupt. Sorry, Paul. Sorry. Are you saying that you first picked it up? Because that would be the cause. You picking it up and dropping it.
Me picking it up is not the cause of it falling.
Well, yeah, you picked it up and dropped it, didn't you? Okay, so I've got a pin in front of me. I've got it right now. I'm looking at it. Right. Why isn't it falling, Brenda?
Because you're holding it.
No. I'm looking at it. It's on the side of my desk, but it's definitely not falling. Are you saying that pins fall of their own volition randomly in nature? That's a phenomena we can observe. Or are you causing it when you pick the pin up and drop it?
No, you're not causing a pin to fall when you pick it up.
Well, I'm looking at a pin and it's just not dropping at all.
Right.
So when you say pin, do you mean pin with the caveat that a man's got to pick it up and drop it? Because I would say that that's the cause, wouldn't you?
No, I wouldn't say that picking up a pin causes it to fall.
Okay, again, I'm looking at a pin and it's not falling.
Right.
Yeah, so it's not falling, Brenda, so it doesn't fit the criteria. How am I going to measure it falling if it's not doing that?
Well, you would pick it up.
Oh, well, that would be the cause of it falling then, wouldn't it? You picking it up. There we go. Cause and effect established. Jolly good. So you're causing it to go up in the air. You're giving it energy by picking it up.
Right. Yes.
Well, that's the cause. That's your cause. That's your cause. There's your cause. There's your cause. There's your cause. If you hadn't picked it up and dropped it, it would have just done what my pin's doing, which is not dropping. So there's your cause. Not gravity. You picking it up and dropping it.
No, that doesn't follow at all. So suppose I pick it up and hold it. Will it fall?
Well, that depends on whether or not you cause it to fall. But that would be you causing that, wouldn't it?
You don't cause the pin to fall at all.
It's not falling. I'm looking. I keep telling you. This pin I'm looking at's not falling, Brenda. What are you talking about? Pins don't just constantly fall. I'm not looking at pins coming down as rain. That's not a natural phenomena. Pins don't just fall. Unless there's a cause. Unless there's a... I hadn't finished. Unless there's a cause for them to fall.
Right.
And in this instance, you're saying, well, I'm going to pick it up, and then I'm going to figure out what the cause is. Well, no, we established it when you said you picked it up.
Well, picking it up doesn't cause it to fall. Picking it up causes it to rise off the table, doesn't it?
So things go up then. Wow, hold on. So hold on. We've just got some anti-gravity going on. That's anti-gravity then.
It's not. It's a force. You apply a force to the pin, causing it to rise off the table.
Oh, right. So there's your cause then, like I just asserted.
Yeah.
All right. No need to do any further science then. We've got our cause. Cause and effect has been established. Excellent. No need to go further and establish any causes of any effects. We know what the cause is, don't we? You picking it up.
Picking it up off the table doesn't cause it to fall.
No, it went up.
Yeah. Yes, it did.
Well, that's completely flying in the face of gravity then, isn't it? So apparently things always go down, but in this instance, they're going up.
Right. You think something going up means that it goes down?
Well, no, you're saying it goes up. You've just described it going up. You pick it up and it goes up. We'll ignore the fact that you're doing that, and I'm just going to assert there's a natural force of up, because if you pick up a pin, it goes up. So the cause of that is the upward force. Forget that I picked it up.
You caused.
No, I didn't. There's an upward force. There's nothing to do with me. It just went up. I didn't pick it up.
Even though I picked it up. It's an upward force, you dumbass. The upward force. It's not me picking it, Brenda. It's not me picking it up that causes that. It's the upward force.
Yes, it is.
Oh, really?
Yes, it is.
So you're now fighting my argument, are you, Brenda, you complete dumbass?
No, I'm not.
So it's not me picking it up, you say?
No, it is you picking it up.
Excellent. So it's you picking it up, Brenda. Yeah. So we're in agreement. You picking up the pin is the cause.
Picking up a pin causes it to rise off the table.
Excellent. Well, that's in complete defiance of gravity. Man, this is just not going well at all. I thought we were trying to prove a downward force, but yet all we've got here is things going up. It's incredible.
You brought it up, Nathan. Shut the fuck up.
No, I didn't bring up picking up a pin, Zinder. Is that another lie?
You didn't bring it up. You said it defies gravity picking it up. Why are you...
Oh, really? Sorry, John.
Right
John, can you just bring up your screen again with what is apparently my claim? We'll just put it back up on screen. Sorry.
Picking it up doesn't defy gravity.
Oh, have you deleted it already?
I'm back on the screen here. What did you want exactly?
I think you've deleted it already when she gave her alternative hypothesis of a pin being dropped.
Oh, I took that off. I'm sorry.
Oh, yeah, but it definitely wasn't my claim, was it? It was Brenda's.
No, she said it was Newton's hypothesis that he never hypothesized.
So picking it up doesn't mean that it necessarily must fall down.
So things don't fall down at all now. So there's no downward force ever. No downward force then.
Necessarily. I said picking things up doesn't mean that they have to fall down. I can just hold it. Right? I can just hold it there.
So how does this affirm your argument in the slightest, Brenda?
Well, because when I release the pin, right?
Oh, when you release the pin, Brenda? When you release it. Oh, okay.
Yes, when
Continue,
I
I'm sorry.
Oh, great. Well, we've got a cause of that as well. You releasing the pin is the cause of that occurrence, isn't it? You caused that to happen, Brenda, now didn't you, when you released the pin?
No, when I released the pin, I didn't cause the pin to fall down.
No, and I didn't cause it to go up when I picked it up. It just has an upward force attached to it. Didn't you listen to me, Brenda? I'm not causing the pin to go up when I pick it up. That's not me doing it. There's an upward force.
You don't think the upward force is applied by your muscles picking it up?
No. Oh, no. I've got nothing to do with it. We'll just figure out what the force of the up bit was, ignoring that I did it. Like you're going to ignore you dropping it, right? It's nothing to do with you.
That's correct. It's nothing to do with you.
No, that's right. There's an upward force, and when people pick pins up, it's nothing to do with them. It's just the magical force of up.
When you pick something up, that has everything to do with you, but when you release it, the reason it falls doesn't have to do with you releasing it.
So it doesn't have to do with, and then she describes the thing that caused it being me releasing it.
Gravity takes over.
No, the upward force takes over when you pick it up. The upward force takes over. It's nothing to do with me when I pick it up, Brenda. It's the same principle. It's nothing to do with you dropping it, and it's nothing to do with me picking it up in the air. It's the same.
Right. So when you pick something up off the table, you apply a force to it.
No, I didn't. I didn't. No, it's not me. No. Fundy. No. Stop misrepresenting me. Stop it. Brenda, stop rumpusing. Stop rumpusing with your nonsense. Brenda, can you stop rumpusing?
Pick something up.
Brenda, I'm going to have to kick you out if you keep rumpusing. Right, it's time for Brenda to go. She's obviously lost so badly that she's going to keep rumpusing. Is this what you're going to do? Is this what you're going to do, Brenda? Keep rumpusing, I'm going to kick you out. Right, time to kick you out. Bye-bye. No rumpusing, sod off.
Okay, let me take over.
Oh, great.
Hold on. Does picking up a lead weight require a force? Your muscle, does it? Yes, I think so. Does letting the lead weight fall require force?
We first started to get it up in the air, though, didn't we? So, again, you couldn't have the second scenario without you first picking it up, Zinda.
But that is not a cause. It is like saying me pushing the button of an elevator is the cause for the elevator going in on the top floor of a skyscraper. It isn't. It is just you pushing a stupid button. Everything else makes the elevator.
So what's your claim?
Would the elevator come to your floor?
Hold on a second. Are you claiming this
button.
force is gravity?
What?
Are you claiming, Zinder, are you claiming this force as gravity?
No, I don't know what the force is. The force is just a 9.81 meter per second squared downward force. That's all I know.
Yeah, but you're calling it a force. How do you know it's a force?
Because when I let it fall, because when I let it go, I needed a force to pick it up. I need a force for it to go down again.
So you're saying there's a force there. Hold on a second.
What force is causing?
Oh God, this is. We need slick moderating here.
Try once.
Whenever you're ready.
We need some common sense in here. Is what we need.
Yeah, I know.
So what force is?
So what are you claiming,
force causes
Zinder?
the balloon to go up?
What is happening here is that when you pick up the pin, you're putting energy into the pin. When you release the pin, that same energy that was used to pick it up is released and it goes back to where it was.
That's not true, because when you hold the pen for 1 hour, there is a lot of energy that is required for you to hold the stupid pen. But when you release it, the same energy gets released as if you would only hold it up for 1 minute.
Okay, now with that scenario, I can pick up a pin, right? And I can set that pin on a table and let that pin sit there for a week. And then I can come along and just nudge it. And that same energy that I put in it when I put it on the table, that held there for a week, will release itself and the pin will go to the floor.
Well, in that scenario, the table has probably a structural integrance that would hold the pen up. But in my scenario, when I lift it up with the arm, I need energy to keep my arm in the air. and there is a lot of energy getting built up. That means that the longer I wait with the pen in my hand, the faster it should fall, or the harder it should hit the ground, whatever, it's the same. But it doesn't happen. The pen will always...
So wait, so if I hold a pen for hours, it's going to fall faster than if I hold it for 2 minutes?
No, that's what you propose when you say that the reason why the pen falls is because I picked it up.
Okay, what is the cause?
The cause for it falling is a 9.81 meter per second square.
No, that's not a cause. That's an effect. So what's the cause of that?
A force pulling on something is a cause for something moving.
Okay, so we got a little thing called the scientific method that elucidates cause and effect relationships. So let's go through it. Is my screen up?
I don't care about your scientific method.
We'll start off. It's not my scientific method. It's the scientific method. I didn't make it up.
Oh, sure. There are a lot of scientific methods.
Observe phenomenon. The scientific method. It's singular, not plural. Method. Do you have another scientific method?
All right, let me say something. Like, the scientific method, in actuality, isn't a set of sequence of procedures that must happen.
It isn't?
No, it isn't. That's from your citation that you posted in Discord 1 month ago, by the way.
Citation, please.
All right, I can cite it.
And then we're going to need an example of you taking us through this method that you're going to post.
How many scientific methods are there?
1.
Seemingly a lot.
1.
I mean,
so can you count them?
All right, let me finish. That must happen, blah, 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 although it is sometimes presented as such.
Did you say blah, blah, blah?
Yeah, all right, I'm going to repeat the sentence I said before, all right? The scientific method, in actuality, isn't a set of sequence of procedure that must happen, although it is sometimes presented as such. Some descriptions actually list and number 3 or 14 procedural steps, right? That's what it says. So we have a lot of different sources that say different things about the scientific method, but at the end, it seems to be a semantic game again. So why should your scientific method, or why should the scientific method you talk about be the right one? Can you show me any evidence for it?
Well, you are in this channel, on this channel, as a certain scientific method. So if you don't agree with that method, then maybe you shouldn't be on this channel.
Yeah, no. There's only one method. He had his say. He said there was different scientific methods, correct?
Yeah, like 3 to 13 steps, it says.
Okay, so can you give us those steps? No, we want an example. We want you to take us through scientific validation of a claim through one of those methods.
You claimed science. I didn't. I didn't even say that my example follows the scientific method. So no, I don't have to take you through any scientific method.
Well, there's a cause and effect relationship, right? That's what the scientific method adjudicates.
So what? I don't care about your
We're looking for
scientific
validation.
method. Why should I follow the scientific method with what I just said?
Because it's a cause and effect relationship. You just said that before. That's why we got on the subject, Zender. Are you on medication?
I described to you a 9.81 meter per second squared downward force, right?
That's an effect.
That's all.
What's the cause?
Wait, I just want to know.
Wait. That's an effect. What's the cause?
The cause is the force pulling down the pen.
Okay, so we have to scientifically validate.
Do
you agree that the king of the scientific method is experiment?
You brought up the scientific method. I don't have to go through the scientific method again. Why should I?
Scientific method, right? What is the scientific method? Let's start there.
All right. One example of it is for example, here a hypothesis, like here it says the hypothesis should also contain a prediction about its variability. For example, if the hypothesis is true, then 1 should happen when 2 is manipulated, right? That's the...
Right. So what's 1 and 2?
So 1 would be the dependent variable, and 2 would be the independent variable.
Well, that's correct. That's what I was going for. Here we go.
Yeah, but I don't have to follow it because I didn't claim science.
So what are you claiming?
I claim that a force pulls down the pen.
Oh, that's the cause of the pen. So that's cause and effect, right?
Do I have to follow the scientific method
to
describe how I ride a bike?
Well, Zinder, we're asking because Brenda declared that the gravity went through the scientific method. So
do I sound like Brenda, Chocolate?
No, you don't. But you're on her side, right? You're fighting her fight, right?
No, I'm not.
Look, you're not claiming the scientific method for the force of gravity being 9.8 meters per second squared. So how is that being measured?
That's an
How is your
observation.
claim?
That's an observation. The 9.81 meters per second squared is an observation.
How do you measure that speed? Do you have like a
You take an object in a vacuum in order to eliminate the...
Where'd you get the vacuum? But that's not a natural phenomenon.
No, let me finish. You take an object in a vacuum in order to eliminate air resistance. Because air resistance is the thing.
Where'd you get the vacuum? Yeah, but stop. This is natural science. Where did you get a vacuum?
I'm not talking about science. I'm not talking about natural.
Well, we're in the business of scientifically validating claims here.
I'm not talking about science. You are the only one here who's talking about science.
That's right.
Look, let him explain. He's not talking about science. I want to hear his claim on how it's not science that he's claiming that it's his fact, I guess.
Well, an observation of an object falling down in a vacuum can show you the acceleration of every object, no matter if it's a feather or if it's a stone, will accelerate at 9.81 meters per second squared. That's an observation.
In a vacuum? In a vacuum?
Yes.
Well, what use is that? Are we in a vacuum?
It doesn't matter.
Well,
it
no.
Still applies
hold on.
Object.
Zinder. If you're to say there is a force, and I say, what force? You say, well, we observe it. And I say, well, where do we observe it and experience this force that you say exists everywhere? And you go, well, I put things into a vacuum. And I go, whoa. What do you mean you put things into a vacuum? I'm not in a vacuum. So what relevance does this have?
Well, in air, maybe it accelerates a little bit slower because of air resistance. So what?
So things don't fall at 9.8 meters per second then?
They do if you eliminate air resistance.
Yeah, but we do have air resistance.
So they fall a little bit slower because...
So what's the relevance then? So they don't fall at 9.8 meters per second, as you're asserting. They only do that in a vacuum when you remove the medium that we live in. So this is totally irrelevant to anything.
That's the force I described as 9.81 meters per second. That's the
force. That force only happens in a vacuum, according to you.
No. It
doesn't happen in the world, does it? You said it's a bit slower. So it doesn't happen in the real world, Zinder. It only happens when you completely remove all of the necessary ingredients for life. For me personally, I like air. But you're saying if I remove the thing that you necessitates life for you personally, then we have this measured force at 9.8 meters per second. Therefore, that is the force.
The force applies everywhere.
Yeah, I know your fundy belief. I get your fundy belief. I've heard it. And when we ask you where we observe it, you say in a vacuum. Hands up, who's got a vacuum?
I've got 2 vacuums. Actually, 3 vacuums.
So,
but Zinder, how fast does a helium balloon in a vacuum fall?
9.81 meters per second squared.
A helium balloon.
Yes.
A helium balloon?
Yes.
Yeah, in a vacuum. Is that the same as what happens in the real world?
Isn't the vacuum in the real world, Nathan?
Sorry,
I think
my question,
Zinder.
Zinder. You said both, whatever you pick, a bowling ball and a helium balloon, both fall at 9.8 meters per second in a vacuum. Is that statement correct, first of all?
Yes.
Is that what happens in my existence generally?
In air, no.
So when you assert that items are pulled to the ground at 9.8 meters per second, and then you put the example of a helium balloon in there, would you not assert that that effect only happens in a vacuum?
The acceleration of the object happens at this acceleration, yes, but the force is still the same.
Well, but it isn't. Sorry, you're saying the force is... Sorry, Zinder. If the force is the same, then objects like helium balloons would also fall with the same rate in air, but they don't. So I'm saying that that effect of objects always falling at 9.8 meters per second only applies in the very unnatural scenario that you set up when you do this and claim it's an observation we see every day in a vacuum that we don't live in.
Well, the helium balloon goes up, the air goes down. So yeah, the air falls down while the helium balloon rises.
Oh, so the air resistance is negative. Is that what you're saying?
No.
For a helium balloon? So how does the helium balloon rise up not in a vacuum?
So why does the helium balloon drop in a vacuum? Or why?
No, why does the helium balloon rise up when it's not in a vacuum? Is it because the air resistance is negative?
No, because the helium balloon goes up, the air goes down. It's an exchange.
But why does just a normal balloon filled with air fall down slower than 9.8 meters per second squared?
Obviously, it is slower, yeah. Because there is an interaction between the air and the helium balloon.
Okay, you're saying it's air resistance, right?
Yes. Air resistance slows down the air going down.
So that's your cause.
Does the effect going up have air resistance?
Yes. I mean, it has to hit the molecules in order to go through the air, right?
The thing is, Zinder, the very thing that you've removed from the equation, the air, when you put it into a vacuum, seems to have quite a strange effect on the assertion made that things always fall at 9.8 meters per second squared. So would you say that that particular variable, given that when it's reintroduced, completely alters that assertion, would you not then surmise that perhaps the air itself has got quite a big factor on what things are doing and why they're doing it? For example, going up, not down.
Obviously, the air has a factor. And
right.
I didn't say that everything, by the way, I didn't say that everything falls at 9.81 meters per second squared. I said the force is measured as 9.81 meters per second squared. Because you have to eliminate all other variables in order to measure force.
You said everywhere, or you introduced your vacuum. Where do we find a vacuum in nature?
It doesn't matter if it is
this
in nature
is natural
or not.
Science.
I'm not talking about science. Why do you
this is natural science. You say you're not talking about it, but you are talking about it.
I'm not claiming science. I'm just experiencing
This is
things.
natural science, son.
Let me try to help Zinder out just a little bit, maybe. Everything you've described is you're varying the one thing that is potentially the cause is the air. The one thing you can't vary is the force. Everything, removing air in the vacuum, the balloon rising, the pin falling are all the variables. And you can adjust that according to density and buoyancy, the whole 9 yards. But the one thing you can't control is the force. You have to vary the force, not the medium in which all the objects are in. I think that's where you're getting this all wrong.
Yeah, I agree. I can't vary the force. The force always stays the same. Everywhere.
Or there is no force.
You just dream this up. You're just dreaming up a force. I can call it anything. I can say it's Dukel-Slopelgertz, right? I could just claim it, declare it. So
the acceleration isn't the same in water either, and it's not the same if you tank of helium. If you vary you're varying the material, whatever you're in. If you're in a tank of air or you're in a tank of water, it's not so it's not the same everywhere. It depends on what. Yeah. The force is not the same everywhere. It depends on the medium that the object is in.
So I think what Nathan's saying is it's medium specific, but you're saying that to declare there's a force, you get rid of the very thing that if you did vary it, you'd see alterations. That would be the medium that the item passes through.
All right, so we have a motor that has the same force always, right? It spins and it has a rope attached to it. At the rope, I'm holding the rope, right? And in the air, I am really fast, right? I'm getting direct really fast, but then I'm getting direct through water. Then I'm slowing down. The force that is the motor is the same, but the speed of the person changes. That's the same with the force we experience when we let something fall in a vacuum. That's exactly the same.
Sorry, you say sorry, we experience. When do we experience? Have you experienced this in a vacuum?
Yeah, I'm experiencing a force right now.
In a vacuum, you just described it in a vacuum using the words "we experience." So have you experienced this in a vacuum?
I've observed it doing things.
Can I get a quick question in there just so I can get a little bit of clarity because I'm a little bit confused? Zender, in the vacuum, that thing that falls, is it sitting in the bottom of the vacuum when it falls?
No, it was at the top.
Okay, so how did it get to the top?
Someone put it there.
Right. So now when someone put it there, didn't they need energy to put it there?
Yes.
Okay. So now isn't it reasonable to say that when they let that go, that same energy that they put in it just released? Is that a possibility?
It wouldn't be the same energy.
I know.
Yeah.
Okay.
I mean, the energy isn't the same. I'm sorry.
Right, but I'm saying is, okay, here's the question. Let me ask it this way. What happened to the energy that they used to put it up there? Where did that go?
That became potential energy on top of the vacuum chamber.
Got you. So now when they let it go, what happened to that potential energy?
A part of it got released, but not all.
Okay.
Probably less of it got released than it was needed to put it up.
Okay, what happened to the rest of it? Hold on. What happened to the rest of it? Because energy listen, let me explain. Energy can't be created or destroyed. Yeah. So if you put potential energy into that item and only half of it got released when it let go, what happened to the other half?
It transformed probably into heat. And into heat as firm, like, I don't know, into radiation. Form of radiation, in form of anything.
Okay, so it started glowing in the vacuum chamber.
Yeah, where'd you get the heat from? What was creating the heat? Was it through friction with the air that you've removed?
What about radiation? Where'd that come from?
Wait, hold on a second. Don't interrupt this. This is an important point. Go ahead, Zender.
The heat I was describing was created when the person picked it up and put it on the vacuum chamber. That's the energy that's the energy that was required to put it on top of the vacuum chamber.
No, that's not what we're talking about. You said there was, when it released from potential to kinetic energy, not all the energy was released. You said less than half. So, and then you said that the heat from, what are we talking about? A pin or a feather? Doesn't matter. Was released somewhere. So where was it released? And then you said it was radiated. Do you know the three types of heat radiation?
So no, that's not what I said.
It is what you again. Said. I wrote it down.
So he said if the same he asked if the same energy got released as it was required to put it on top. I said no. A part of the energy that was required to put it on top was released in form of heat. That's what I said.
in the form of heat.
Yeah, like he picking it up and putting it on top of the vacuum chamber.
No, when it was released. You just said it when it was released.
No, the energy was released in form of heat when he picked it up and put it on top of the vacuum chamber.
Oh my God. Okay, where's the energy? Where is, I'm out of this.
Not released as if in me letting go the object and then the object getting released. Releasing the energy was released when he made the movement. Right?
I don't know. I'm sorry. You asking me?
Where are we going?
Wrong.
I'm lost.
No, see, it's a labyrinth of incoherence, is what it is. He says something that he says he didn't say it, but he just said it, and then he said it again, and he said he didn't say it. I mean, are you on medication? Seriously.
Can I make an observation about Zender's vacuum chamber that he probably hasn't thought of? Is there any mechanisms inside the vacuum chamber that are carrying this object up to the top of the vacuum chamber?
My example was me just picking the object up and putting it into the vacuum chamber and then like pulling away the air, right? So after I put it inside.
Okay, I don't understand that. That's incoherent.
No, it
most vacuum chambers I've seen is they have mechanisms inside to raise either a feather or a bowling ball up to the roof of the so-called vacuum chamber. Now, the question I have is the objects inside the chamber more dense or less dense than the air inside or the lack of air inside?
So, like, this, for example, let's take a piece of metal, so we can raise it up with a magnet, right? So we have the mechanism, right? And so the magnet or the piece of metal is obviously more dense than nothing, or than almost nothing, right?
So if that mechanism that's made of metal or a magnet is holding a feather or bowling ball at the top of the chair, is something more dense holding it in the air than something less dense?
Like the mechanism itself, if it is more dense, or if the object inside. Yeah, the mechanism is, I would say the mechanism is outside, because the magnet would have to be outside the vacuum chamber in order to hold it.
No, I mean, okay, well, okay, let's just put it back in the air. When I pick up a pen, is my hand more dense than the air that's in, or less dense? More dense or less dense?
More dense.
Okay, so my dense hand is actually supporting the pen in the air, correct?
Yeah.
If I let go, the more dense pen gets released into the air, so the more dense pen drops to the floor, which hits a more dense surface, which is the floor.
Mm-hmm.
Correct?
Yeah.
You see where I'm going with all this?
Yeah, you say relative density explains why things fall to the ground, right?
Yep.
Okay.
Because that's the only thing you can control. There's no force involved.
Well, yesterday I think I made an example with like me when, like, you know, when you are upside down with your head upside down, you all the blood rushes into your head, right? So relative density didn't change. You can eliminate facts like pressure differences by going inside a something, or going inside a shield or anything that shields you from the density outside, like the air pressure outside. And then you stand upside right, and then you slowly, really slowly turn around so your head is at the bottom, right? Now your relative density didn't change, but the blood flows into your head.
Can I get a little clarity here? No, I'm sorry. Go ahead.
I'm losing my will to live.
Yeah, I would like to have a conversation with Zinder. So,
people.
You're saying that there's a vacuum in space outside of Earth's atmosphere without a container, but what keeps things from flying outside into the vacuum is the gravitational force of on Earth, right?
Just the force, like
the force, but it has to be gravitational force on Earth because if they say the gravitational force of the moon is a lot different, it's 1/4 of the gravitational force of the Earth, right?
Mm-hmm.
Now, water vapor in a vacuum, how does it form into a cloud? Does it ever condense?
Like a water vapor on Earth,
in a vacuum
of the Earth, on the surface of the Earth in a vacuum, would just distribute itself completely around through the vacuum chamber, and would like it would at some point, I think, it would have to I don't know how it would work. Part of it would become water if the pressure is high enough, because there is water vapor inside, right? But at the end, it would just be a gas. It couldn't form to a liquid.
It wouldn't ever form to a liquid, even with gravity?
If there is enough, like if there is a complete vacuum, even with gravity, it couldn't form to a liquid.
So the water vapor on Earth, the gravity is condensing it to clouds with a vacuum outside of the atmosphere on Earth. So what causes that condensation to form rain clouds? Like at what point in the atmosphere does it work with the vacuum pulling on the outside of the Earth's atmosphere and the Earth's gravity preventing that water vapor from escaping? Like how does it form?
So how do clouds form, you say?
Yes.
Like the atmosphere has a maximum amount of water it can take, right? That's called like when you hear like 100% air humidity, it is at 100% air humidity. There is no more, not much more water that could be pulled, let's say pulled up from the atmosphere. So it is completely satisfied, right? And then the water vapor rises up to a certain point until it I have to add the water has to stick to a solid object in order to form a cloud. It doesn't work if it isn't stick to a solid object, right?
What's the solid object?
Dirt.
Sorry, I'm a bit sorry to interrupt. Clouds don't stick to solid objects.
They have to.
Sorry, show me a cloud attached to a solid object, please.
All right, look in the air. Look how clouds form.
I'm looking right now, and I see no solid object attached to the cloud.
Yeah, you can't see dust from, I don't know, 2 kilometers away.
Oh, okay, I see. So you're saying in order for it to form, it needs to form around a particulate. Okay, my bad. I take it back. I take it back.
Because without dust, it can't form to a cloud. And don't ask me how to explain it completely, because that's just the mainstream that I got it from, right?
Thanks.
But
okay, now can we get to the meat of the subject? Can you please provide scientific evidence for your spinning ball religion?
No, I never claimed science.
Okay. Thank you.
Perfect. Anyway, got to go. So.
Okay. I mean, I like this conversation, Zinder. Now, those dust particles, how do they get up there, up into the atmosphere? I mean, wouldn't those dust particles fall due to gravity?
Well, I mean, I don't know. Like, or if you look at it from the relative density thing, a dust particle is usually more dense than air, right? I don't know how it gets up there. There is wind. There is wind that like brings it up. There are like air currents. The Earth is a really complex system, so I have no idea.
I'm sorry, is that Ebon? Is that your name, Ebon?
Yes,
am I saying that correctly?
me.
Hey,
yeah.
Ebon, you invoke gravity in your question. Where'd you get that from?
No, it's just I just want to learn more from Zinder about how gravity and vacuum kind of work in relation with water vapor, dust particles.
Wait,
air,
shouldn't we, before we go extrapolating down, making a question fallacy on acid, shouldn't we establish what gravity is?
Well, Zinder can establish it however way he wants. It doesn't have to be scientific. I just want to hear how it's formulated in his mind.
What do you mean?
I don't know what gravity
is. That's what science says. No I've seen in the science book, gravity, it has to be science, right?
But he's not claiming science.
Hold on, he's just said he doesn't know what gravity is. Is that right, Cinder?
I have no idea what gravity is, yeah.
So how the hell would you know that it holds the atmosphere?
Well, I can look at something and see its effect, but I don't know. I don't have to know what it is.
Like, don't know what it is. How do you know it's the effect if you don't know what it is?
Well, I experience it. I experience a force.
No, you don't.
But then we go back.
No, we went through this. No. We went through this earlier.
I'm sorry.
No. The force you described, we went through earlier, and you said that's demonstratable in a vacuum. So no, you don't experience that. We went through this earlier. No, that's not part of your experience. Things falling at 9.8 meters per second. You don't experience that. In fact, that never happens. Ever.
Never, ever?
No, not in your experience, no.
It's me looking at something, experiencing something.
So you can look and watch and experience anything ever falling at 9.8 meters per second. That happens, does it?
No. But it's me watching
so it doesn't happen. That's my point. What do you mean just no and then carry on talking? So it doesn't happen ever.
It happens.
In your experience, that happens, does it? We're going around in circles, Inder, with you declaring that you experienced this, only to then confirm it never happens ever.
I didn't confirm it.
Yes, you did.
It's me looking at it. It's me observing something and experience.
Yes.
Yeah. Yes.
So
Are your eyes calibrated? How do you know it's 9.8 meters per second squared?
Because it was measured. The speed difference was measured.
Where is it measured?
Observe.
Where?
In a vacuum chamber.
Well, that's not your experience then, is it? That's in a vacuum chamber. That's in the experience of a vacuum, not your experience then, Zinder. So the problem being that experience, the experience of a vacuum that no one's ever experiencing, is completely contrary to what we actually experience when you declare there's a force that you don't know what it is at 9.8 meters per second in a vacuum, not in your experience. In fact, the experience is completely different. Helium goes up, yeah?
Is me watching something experiencing something?
So you experience...
Is it only in German?
So you experience helium going down at 9.8 meters per second. You experience that, do you? In your experience, that happens, does it?
When I see something, I experience something.
Yeah, so you experience 9.8 meters per second towards the ground when you release helium. Do you, Zinder?
Depends where it is inside.
No, just in our experience. We're talking about our experience. Reality, Zinder.
The real world. The real world is everything that is a part of the world.
Yes, and in that, do you experience helium following this 9.8 meters per second acceleration towards the ground in your experience or not?
Yes.
So helium goes down.
When it's in a vacuum chamber, yes.
No. Are you stupid? God. Do you know what in your experience means? When have you experienced a vacuum? Go.
When I looked at it.
That's experiencing it, is it? So if I look at a Lamborghini on my screen, that's experiencing a Lamborghini?
No, when it's not, then you experience.
Yeah, when I get inside that Lamborghini, I'm experiencing it, though, aren't I? So when are you getting inside a vacuum and experiencing it in your day-to-day experience? Does that ever happen? Ever? Have you ever been in a vacuum? So you've never experienced a vacuum? Let me get it straight. You have never experienced this. Precisely my point.
I experience vacuums all the time.
When?
My lung is based on forming a vacuum.
Wait, Zinder, you don't see the double speak that you're doing right now? You can't hear it at all.
I'm just playing a stupid semantic game. What's your point?
Okay.
Like everyone here does.
So when you watch the astronauts go to the moon,
no, what you're doing is making your horse's ass out of yourself in front of how many people are watching?
Is it even live? I can't even see the live debate right now. So since like a lot of time.
So you're not experiencing it?
Yeah, 150 people watching this now, Zinder.
Oh, great. Are you streaming on Nathan Oakley or Nathan Oakley 98?
Indeed, Nathan
Oakley normal, perfect.
Yeah. Yep. Yeah. Everybody's witnessing what a horse's ass you're making out of yourself, sir. Good job.
I'm just playing a semantic game. I don't care.
Yeah, you're just playing semantics. What does semantics mean?
Like different meanings of words, for example.
So, would you say semantics is kind of important when people attempt to communicate with each other?
Sure.
So, what's your point?
The question?
But the semantics are important in the context. Semantics are completely useless if you take it word by word.
so the meanings of words are completely useless if we take it word by word.
You need the context of words.
We need a context of words. Give us an example.
Yeah, words alone don't mean anything. You need a context to the words.
Okay. Give us an example. Like, let's say in our experience, right? The semantics of the word helium balloon rising, not falling at 9.8 meters per second squared.
Yeah, when I mean air, or when the helium balloon is in air, I experience it rising. When it is in a vacuum chamber, I experience it falling. What's the point?
Oh, you don't experience a vacuum chamber. Do we live in a vacuum chamber?
Like when I looked at a vacuum chamber, I experienced a vacuum chamber.
Yeah, man, anybody who wants to own a Lamborghini and fully experience a Lamborghini, just look at one and you will get the full experience. You don't need to save up. You don't need to buy one and drive one. Just look, then you experience fully. Like Zinder looking, because that's a total experience, isn't it? That's in your experience because you've looked.
Or if you want, can I tell you my experience of a balloon?
Hey guys, I was trying to get some clarity for about 5 minutes from Zinder. Can I just get this one clarity?
No, let me just respond to it. Like, okay. Is it in English? Don't you say I experienced a movie in a theater, or is it wrong? Is it a wrong sentence?
Yeah, if you were to assert that you'd experienced hell because you were watching a movie of hell, then yeah, that would be semantics, wouldn't it?
No, I asked you a question. Do you experience a movie in a movie theater? Yes or no?
Yeah, I experience a movie in a movie theater, but I don't experience the fires of hell because I've watched them on a movie screen.
No, you didn't, obviously.
No, so I didn't experience the vacuum by looking at it.
I didn't look at the vacuum at the screen.
Can I just get some clarity? Hang on, just to get, guys, I've been trying to clear.
Let's look at this.
Yeah, go ahead.
I was trying to clear up a point for 1 second. Zinder, you said a little while ago that you were just here goofing around, correct?
Yeah, I'm playing a semantics game.
Okay, I heard you. Now, when you said about this force you were talking about, you were just playing a semantic game. You were just kidding. You're not really serious about this force. You're just playing with us, right?
Sure, I'm always playing when I'm come here. Sure, why not?
So this force that you're talking about is just a joke, right?
Yeah, everything is a joke. Like,
okay. I just wanted to clear that up. I just want to clear up for the audience that gravity is nothing but a joke that people play games with. When they make these declarations, they're just kidding. They're not serious. So don't take them seriously. When somebody's talking to you about this force that pulls things to the ground, they're just playing games with you. It's just a joke. So don't get involved in it.
Yeah, I would agree with that. Zinda's declaration that it's just a joke and a game of semantics rather than actual scientific evidence of some force that we experience. But with that, I will say, unfortunately, to the live audience in the Nathan Oakley channel, this is where we bid you farewell. If you need something to keep you occupied after this live stream has ended, then go to nathanoakley.com and check out the Flat Earth Debate Forum to keep up to date with the community debate. If you're watching on Nathan Oakley 1980, then stay tuned, as there will be an after show to follow. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!